Hello everyone. In this video, I will be discussing about the register set of 8085 microprocessor. What are the different registers and their uses in designing the programs? How these registers can be used. That will be discussed. So it would be helping the knowledge, gain knowledge in the 8085 architecture because the registers are a part of the architecture. So it would be helping you gaining a knowledge in the architecture of 8085, and obviously you will be able to write the programs. That is a main objective of this one. So the types of the registers, there are different types of registers. First of all, it is 8-bit general purpose registers. We are having 16-bit registers. We are having temporary registers, special registers, and 16-bit registers. Onto these registers, we will be discussing. First, we will start with 8-bit registers, discussing on 8-bit general purpose registers. Then I will be discussing on temporary registers, special purpose registers, and 16-bit registers. That is this one. So let's start with this one. General purpose registers are 8-bit general purpose registers. There are totally 6 general purpose registers, naming it as B, C, D, E, H, L. So these 8-bit general purpose registers are used for any general operations like when you go for adding of numbers or subtracting of numbers or any other operations, whether you for intermediate storage of data in the program, storing one value over here to the program, then these registers are used, which should be like B, C, D, E, H, N. Totally 6 registers are there. And now these 6 registers, out of these 6 registers, there is a one provision that you can combine these 2 registers. Now each is an 8-bit register. When you combine it up, it becomes as an 16-bit registers. So the register pairs which are possible, you can't combine any other 2 registers, but there is a specific which can be clubbed or internally bound. Physically, it won't be clubbed, but it would be like lower order bits would be stored in one register, higher order bits would be stored in the other register. Like C would be stored in the lower order bits, B would be stored in the higher order bits. Like that way, total 16-bit register would be formed. How? By a combination of either B and C registers, or a combination of D and E register, by the combination of H and register. These are the register pairs, fixed one. You can't combine B with D or C with E. Like that way, you can't combine. Only the possible combinations you can have to get the 16-bit registers. When you are required of 16-bit register, then you can go for B, C, D, E, H, L. So in the instruction set of 8085, there is a separate instructions which are defined for 16-bit numbers. So when we are discussing the instruction set, we'll discuss about that. Here, these are the possibilities. So general purpose registers are used to do any general purpose operations like addition, addition, subtraction, multiplication. And remember those one. These are less important when compared to the accumulator. The accumulator which we will be discussing in the next one in the special purpose registers. The next one is the temporary registers. The name over here is what? Temporary. Mostly some of the things would be like it would be for a temporary. Then automatically the usage of that one would be erased. Same way, these registers are used for temporary purpose. Like one is a data register which is not used in your programming. So none of the you can't consider a data register in the programming. Another register is W and Z registers. So first of all, what is a data register? So when you are ALU, as you can see in the architecture, there is an two inputs are there to the ALU. One of the input is applied to the accumulator. The other one is a temporary data register. So whatever the data you are processing in ALU, it comes from accumulator. The other one would be followed from the data register. So the immediate data value is stored in the data register and it will be gone for processing. Before going to processing, every data will flow to the data register. That is only in that architecture you do there, and you can't use that data register. Internally process, it will be stored into the data register, but you can't use this data register in the program. That is so. Same way you are having Z and Z, W and Z registers. These are 8-bit registers, and obviously the data register is also 8-bit. This is used to execution of some instructions. The data has to be stored for a temporary purpose that are stored in W and Z. These are the two registers which are used for temporarily store age of data during some instructions. The most important register, it is register A, or it is called as an accumulator. Accumulator is an 8-bit register. So where you are going for any arithmetic, logical, IO, or any load and store operation, whatever it is there, mostly for all these operations, the point destination, we go for A register. So mean to say the result of this one addition is there, whatever it is there, A register. For example, if you want to add two contents from B and C register, what you need to do, either from B or C, you need to take the value in compulsory. One of the values should be there in the A, and then add it up. So the add instruction would be like, if you're taking a value from C to the A, add B you need to do. So A content and B content would be added. Add C if you give, A content and C content would be added. So whatever the content is there in the A, if you're not having any content, that dummy value would be added to the filter. Instruction doesn't have like add B comma C won't be. Can't add these two numbers. Not having a provision in its filter. So compulsory you need to go for accumulator. And then when you go for addition, subtraction, whether the number is having a carry or not, whether the resultant is zero, all of this way, the information is given by the flags. So there is some set of flags. 5 flags are there. These 5 flags are arranged in a way, in a form of a register called as a flag list, 8-bit register. Out of these 8 bits, 3 bits are undefined, 5 bits are defined as a flags. These flags will have a discussion in the next class, the next video. So this flag register is a information register or a status register. Similarly, you are having instruction register. What this instruction register does is, what is the purpose of an instruction register? So when we are taking and reading an instruction, each instruction will have an equivalent opcode. That opcode will be stored, we take it from the memory and it will be stored in the instruction register. From the instruction register, it will go to the decoder. Decoder will do the processing and it will give you the what is the instruction it is called. So since the instruction whatever one, according to the opcode, which instruction is called, it will take it to the instruction. That is about the special purpose register. Three are the accumulator, instruction register, and the other one is the flag register. Next one is that 16-bit register. There are two 16-bit registers. One is a program counter, the other one is a stack pointer. These are the two last registers. Program counter is what? Program counter is a special purpose register which gives the next instruction to be fetched from the memory. So when we are writing an when you are seeing a program, we are having an 8-bit addition program. We have done the first line. The second line, from where it needs to fetch the second line, that is given by the program counter. So every time microprocessor will see the program counter. Okay, with the address, it will go to the address, it will read the random. Okay. Accordingly, what is the instruction is used? That instruction is been given by the, which is my next instruction that is given by the program counter. Program counter is a 16-bit register which stores the. Why you know that 8085 has a 16-bit address bus. So 16-bit address bus locations are given by 16-bit program. And the last one 16-bit register is stack pointer. So there is a small memory space in the RAM where temporary information is being stored. So like intermediate addresses are there or intermediate values are there. If you want those to be stored, we'll go for a special register called as a stack pointer. Stack pointer is a reserved space where you can go for that memory space where temporary data is there. So the top of the stack is being defined where the stack is there. That value is given by the stack pointer. So when you are defining both these values to the stack pointer address would be a 16 bit. Both these are address registers actually, stack pointer and program pointer. That's the reason there are 16. So these all are your different registers of 8085. So in the next video, we'll be concentrating on the flag register of 8085. Thank you.